These are a few key test before touch principles. These are not all-inclusive, as there are many more, but these capture the basic concept. Also, the intent is not to tell you how to test before touch, but to give you some thoughts based on experience. Always assume all circuits are energized, even the ones which have been turned off, until they have been tested and verified de-energized and safe to touch. Test every circuit before touching. No one should touch any circuit until it has been verified de-energized by a proper absence of voltage test. All voltage tests require the proper PPE until the test is complete and the circuit has been proven de-energized. Only after the satisfactory test is complete and the equipment is safe to work on can the PPE be removed. It is essential to have knowledge of the circuit, switchgear, or equipment to be tested. If the continuity of the work is broken or a major change occurs, always retest the circuit. Testing for the absence of voltage, or test before touch, is different than troubleshooting a problem in a circuit. Different types of test meters and approaches are used for troubleshooting, whereas the purpose of test before touch is to verify no voltage is present. Arc flash protection is mandatory inside the arc flash boundary. Proper arc flash PPE is also required for testing any high-energy circuit. The 2017 National Electrical Code requires warning labels of high energy to be placed on the switchgear. Once the source has been locked out, tagged out, and there is proof that there is no voltage to the panel, your PPE can be removed. Checking the meter before and after the test is essential. If the meter is not working properly, it could read 0 volts while the circuit is still energized. Just because the meter tested fine before the test does not mean it is working during the test. To verify, retest the meter on a known voltage source. The source must be the same type, AC or DC, as the equipment to be tested. Here's an example why. An incident occurred at one plant when the meter's internal AC circuit failed, but the DC circuit continued to work. 24 volts DC was measured before the AC test was done. When the meter was tested live on a 480-volt circuit, it indicated no voltage. Proving units are a calibrated voltage source. These are used when other voltage sources are not available, for example, in black start conditions. Verify the circuit is off. If a circuit has a visual disconnect, it should be verified the blades are open before testing is done. Load side of the switch should be checked, even if the work is farther downstream, to make sure the automatic device, like a contactor, will not receive power. A test on the insulated fuse cap will not show voltage. In order to avoid mistakes, the fuse holder should be tested, not the fuse. Look to see if the knife blades are open before doing the test. The visual check of the knife blades may find a problem before the meter is inserted. Even though the fuse caps on this style of fuse are energized, as a best practice, testing should be done on the fuse holder. Ground test point depends upon the equipment. This starter has a spring-loaded tab to lock the starter into place. There may not always be a solid connection to ground. The hinges are bolted to the frame of the vertical section. This is a reliable ground test point if the frame is properly grounded. You must absolutely be certain for a reliable ground. The ground-to-phase test is not valid without a good ground. A poor ground connection can cause a meter to show 0 volts, even if voltage is present. The ground test point must be verified if the user is not certain the ground test point is reliable. Verification could include testing a live source using the ground point or a continuity check to a known ground, as mentioned previously. Location of reliable ground test points depend upon the equipment and the manufacturer. Actual ground bus or wiring within the switchgear, if accessible, are the most reliable grounds. A phase-to-phase check is a good backup check for the ground-to-phase test and may find an unreliable ground test point. An ungrounded system, such as a delta system, may not show any voltage ground to phase. The person performing this test must know the system is intentionally ungrounded. This is why a single-line diagram is important and is to be consulted not only to determine the nominal voltage, but also to determine the type of system as well. Sometimes a system which is supposed to be grounded is not because of a bad connection, equipment failure, or even improper hookup. A face-to-face check may find those problems. There are some limitations to face-to-face tests. This diagram is an example of when a face-to-face test will not indicate voltage. As you can see, all three tests will indicate 0. As for induced voltage, what do you do if the equipment that was just de-energized still shows voltage? Most digital meters and some analog meters have a high input impedance and will sometimes show an induced voltage in an industrial environment. Induced voltages are also called phantom or ghost voltages and often will have an unusual value, such as 73 volts on a 120 volt circuit. The induced voltage is caused by a capacitive coupling with nearby energized circuits. A voltage tester with a low input impedance will load the circuit and collapse an induced voltage to 0, verifying the circuit is not hazardous. If a voltage exists after testing with a low impedance tester, the voltage is probably real, and checks should be made for backfeed or equipment failure. Induced voltage values depend upon meter impedance. The values shown here are examples and are not meant to indicate what the value of the induced voltage will be in every case. An analog meter usually has a lower input impedance than a digital meter. A low input impedance meter will typically load the circuit and collapse induced voltage to 0. When verifying induced or backfed voltages, this type of test may require 2 people, or the meter may need to be attached to the circuit. This image shows backfeed. The voltage meter indicates voltage, and the proximity tester is illuminated. This image shows induced voltage. A voltage tester does not indicate voltage, and the proximity tester is not illuminated. Always assume all circuits are energized, even the ones that have been turned off, until they have been tested and verified de-energized and safe to touch. All voltage tests require the proper use of PPE until the test is complete and the circuit has been proven de-energized. Checking the meter before and after an absence of voltage test is essential. If the meter is not working properly, it could read 0 volts while the circuit is still energized. Absence of voltage tests should be performed both phase-to-phase and phase-to-ground. Most digital meters and some analog meters have a high input impedance and will sometimes show an induced or ghost voltage in an industrial environment. We often work in gear that is only partially de-energized. For example, perhaps side A is down for testing purposes, but side B is still energized. In that case, we must barricade off all parts of the gear that are energized so we do not mistakenly enter the wrong cell. Another example: we often work in the back of 1 or 2 cells when testing cables. If there are other cells in the gear that are energized, they must be barricaded off with red tape. If we are working in a switchyard on a transformer or capacitor bank, there are often very similar transformers or capacitor banks in the same yard. We must barricade off with red tape any that are energized. Often, when working in relay panels, the adjacent panels look very similar to the de-energized panels we are working in. These look-alike panels next to our work area are energized and control gear that is in operation. They should be barricaded off with red tape to prevent accidental entry. Anytime we are in a man lift in a switchyard and part of the yard is energized, the energized portion must be barricaded off. At times, we may be testing CTs in a yard breaker which is itself de-energized, but many breakers in the yard are still energized. The energized control cabinets should be barricaded to prevent you from mistakenly entering the wrong cabinet. Safety signs and tags can be used. Barricades can be used in conjunction with safety signs. We typically use red or yellow barricade tape. There must be a tag with the tape indicating the reason for barricading. Different sites have different policies on which color of tape can be used on their gear. Check with the site if you have questions. If barricades are not sufficient, an attendant should be used. Remember, we often work in an environment where much of the equipment looks alike. Anytime de-energized equipment exists in a work area with other energized equipment which are similar in size, shape, and construction, one of the alerting methods previously mentioned shall be employed to prevent any employee from entering look-alike equipment.
This has been a Safety Smarts presentation. Please discuss these points with your coworkers and job team. Remember, Safety is all of our responsibility.